Hello, and welcome to our virtual Lunch and Learn. Today, we're talking about Rockwell Automation's GuardLink network design using Integrated Architecture Builder. My name is Leanne Ireland, and I'm the Corporate Marketing Project Manager here at McNaughton-McKay Electric Company. Presenting for us today is Jim Birdie, Safety and Sensor Specialist from our Columbus, Ohio location. Out in the comments section, ready to answer your questions, is Amy Jenkins, Systems Engineer from our Columbus, Ohio location. We'll also have a Q&A portion at the end for Jim to answer your questions in more depth. We'll get started shortly, but we'd like to allow a few minutes for attendees to join us. As you come in, let us know where you're tuning in from in the comments. We're happy to be able to host these live sessions on YouTube, making it possible for you to be able to join us from the comfort and safety of your own homes and offices. You can view recordings of previous virtual Lunch and Learns on our YouTube channel under the Virtual Lunch and Learn playlist. Be sure to join us every Wednesday on your lunch break. For anyone just joining us, welcome to our virtual Lunch and Learn, Rockwell Automation's GuardLink network design using Integrated Architecture Builder. Let us know where you're joining from in the comments. We'll be looking for questions as you have them in the comments while our presenter, Jim, talks about how Rockwell's machine safety components have been added to Integrated Architecture Builder, including GuardLink. Our specialist, Amy, will do her best to respond to your questions in the comments as we go along. And we'll also have a Q&A segment at the end of Jim's presentation to address some of those questions in more depth and to allow some time for any follow-up questions you might have. If you'd like to reach out afterward, or if you have further questions for Jim, you can send us an email at macamaclive@mc-mc.com. Be sure to let us know which session you attended, and we'll direct your questions to Jim. We'll have that email address on the screen for you at the end as well. It looks like we have quite a few attendees now, so let's get started. Jim, I'll pass it over to you.
Thanks, Leanne. Hello, everyone, and welcome to the McNaughton-McKay Lunch and Learn series. My name is Jim Birdie, and I'm a safety and sensor specialist at McNaughton-McKay in Central Ohio. In today's Lunch and Learn, we're going to explore the use of Integrated Architecture Builder for GuardLink applications. Please note that from this point forward, I'll be using the abbreviation IAB to refer to Integrated Architecture Builder. In today's session, we're going to discuss how GuardLink fits into the connected enterprise. We'll do a quick review of GuardLink technology. There's an excellent hands-on lab associated with GuardLink and IAB, and I'll show you where to find it so that after the session is completed, you'll have a resource available to you. We'll briefly discuss the safety life cycle and see where IAB fits into a safety design, and conclude by opening up IAB and stepping through a GuardLink project. The folks who will benefit most from this Lunch and Learn are those involved in the design of GuardLink safety applications. And if you've never used IAB for your GuardLink design, stick around. I think you're going to like it. Please understand that this is not a deep dive into IAB. For that, I refer you back to a previous Lunch and Learn put on by Todd Turnquist, a PLC product manager out of the Mac and Mac branch in Norcross, Georgia. Todd expertly covers IAB in detail. There's a link to Todd's video in the information section at the bottom of the page. Now, as a safety specialist, I'm very interested in GuardLink. But why should I be interested in IAB? Well, it's because Rockwell has added many safety components, including GuardLink, to the IAB toolset. Furthermore, Rockwell continues to update and develop machine safety features within the tool. For example, one of the considerations when using GuardLink is voltage drop. If you've created GuardLink systems in the past, you're probably familiar with the Excel spreadsheet used to calculate voltage drop across a GuardLink network. IAB now has that capability baked in, and it's a huge improvement over the Excel calculator. So the goal of today's Lunch and Learn is to raise awareness around the machine safety capabilities built into IAB. I'm going to focus on GuardLink, but as you'll see, the machine safety components available in IAB extend far beyond GuardLink. This is a screenshot taken out of IAB. Check out all the machine safety components embedded in the tool, and it continues to expand. We'll explore this further during the demo portion of the Lunch and Learn. Let's look at how smart safety devices interface within the connected enterprise. Notice the GuardLink controllers in the upper right-hand corner of the slide. Also notice the e-stops that are wired directly to safety inputs. This is an example of hardwiring safety devices back to safety inputs. Just beneath the controllers are SIP safety devices enabled with safety over Ethernet IP functionality. SIP is spelled CIP, and it's an acronym for Common Industrial Protocol. Focus for a minute on the Multifunctional Access Box, or the MAB. Notice its path back to the PLC is not hardwired, but through an Ethernet IP connection. The SIP Safety MAB has been included with Integrated Architecture Builder for several years now. New to SIP Safety offering are the 450L SIP Safety Light Curtain and the Safe Zone 3 SIP Safety Laser Scanner. Expect to see more SIP Safety devices in the future. So where does GuardLink fit into the connected enterprise? Shown here is a GuardLink system. So that includes a GuardLink relay, the GuardLink enabled taps, and safety devices. Just left of the GuardLink relay is a Ethernet IP network interface, which integrates the GuardLink safety relay and devices connected to it into the connected enterprise. In the case of SIP safety, the logic solver is the PLC. Safety functions are in the PLC code. GuardLink differs from SIP safety in that the logic solver is in the GuardLink relay itself. All the information about GuardLink networks can be accessed from a standard non-safety PLC like a Compact Logix controller. And you can also use GuardLogix controllers to communicate with a GuardLink system as well. Here's a brief overview of the components that make up a GuardLink system. For more information on GuardLink, I recommend that you go directly to the Rockwell Automation Literature Library and download a copy of GuardLink, the GuardLink User Manual. Also, there are videos on the Mac and Mac YouTube channel that you might find useful. So here's a look at the principal function of GuardLink technology. The 4-wire trunk that acts like a spinal cord joining all the GuardLink smart taps together includes a 24-volt DC wire, a DC common wire, a GuardLink diagnostics wire, and a command lock unlock wire. The DC voltage in the trunk is what powers the devices connected to the taps. So let's take a look at a typical GuardLink application. Here are some safety input devices, GuardLink smart taps, and always on the last tap in the string is a terminating plug. Here's the GuardLink relay, the Ethernet IP interface, a Control Logix controller, and an HMI. Notice the line separating the Ethernet IP interface module and the GuardLink safety relay. The safety portion of the control is on the right side. Everything on the left is standard controls. The GuardLink relay communicates with the Ethernet IP interface and provides diagnostics about the GuardLink devices to the ControlLogix controller. The add-on profile in Studio 5000 populates the tags for the entire GuardLink system. Now just ahead, I'm going to open up IAB and go through an example application. But before doing that, I wanted to point out that there is a hands-on lab embedded in the IAB tool. It's an excellent resource when creating a GuardLink system, and it's conveniently embedded in the lab section of the opening screen, so you don't have to hunt around for it. So when you open up IAB, this is what you see. Go to the Learn section and click on Labs. Next, choose Networks, and there you have it. How to design a GuardLink network using IAB. It's an outstanding resource that covers a lot more ground than what we're doing here today. And this is what pops up when you open up the PDF. As you can see, GuardLink was added to IAB in November of 2020 and updated with the voltage drop calculator in March of this year. I highly recommend that you go through this lab if you haven't already done so. So where does IAB fit into the safety life cycle? When dealing with machine safety circuit design, the safety standards require that the first step be a risk assessment. The next step is determining the functional safety system requirements. Only after those first two steps in the process are completed and the components specified should the safety system and safety circuits be designed. IAB can be an invaluable tool at this stage of the process. IAB is an efficient way to plan and design and ensure accuracy when putting together a bill of material for a GuardLink safety project, but it is no substitute for a proper risk assessment, safety requirement spec, and so on. Okay, we're getting closer to opening up IAB and taking a look at a GuardLink system. Here's a snapshot from IAB depicting a GuardLink safety relay and an Ethernet IP interface module. When a GuardLink relay is selected in IAB, a grayed out group of GSR relays appears. It kind of looks like a chassis, but it's not. As you'll see in the demo, it's more or less a placeholder for GSR relays. There is a limit of 6 GSR relays communicating back through an Ethernet IP interface module, and that's what's being depicted here. If we look at the side of a GuardLink relay, here's the DIN rail. You can see the DIN rail mount, and there's also an optical bus. So every GSR relay uses the Opto 2 bus. That's shown here. Exclusive to GuardLink is the Opto Bus 3. So when you look at a GuardLink relay, you're going to have an additional optical bus. And this is how the information is transferred over to the Ethernet IP module. So before we open up IAB, I kind of wanted to go over the design. Let's assume that a risk assessment was performed, and these are the components that were selected based on the safety requirements. Our system is made up of an Ethernet IP interface, a GuardLink safety relay, a cable pool, a 1200 millimeter long, 30 millimeter resolution light curtain, a SensaGuard non-contact switch, an e-stop, and a guard locking switch. The part numbers for each of the devices have been selected, and the cable lengths for our system have been determined. So at this point, we're going to pull up IAB and create this system that you see in front of you. Okay, I'm opening up IAB. And this is the splash screen that the opening screen that we talked about. And just as a review, here's the labs folder under Learn. And if I go to Networks, here's that PDF, the GuardLink Lab that that's recommended that you go through. Okay, so we can open up a new project, existing project. Well, here's a recent project. So I'm going to open up this base project. And this is what comes up. So what I did here with the help of a PLC specialist is put together there's a compact Logix PLC and an Ethernet switch. And the goal here is to add GuardLink to this switch so that it can be accessed from the compact Logix. And so what we're going to do is add new hardware. So I click on that tab, and here's all the hardware that's available. And notice that here's the safety section, and I'm going to pick a safety relay and select OK. Here's that grayed out placeholder. This is that where it kind of forces you into putting GuardLink parts in the right spot. Okay, I'm going to just make this a little bit bigger. All right, so I go to the device list, and the first item I'm going to do is pick that network interface card. And you can see I can't put it in any of these slots. It only goes here. And again, this is not a chassis, it's just grayed out placeholder. So while I'm here, I'm going to right mouse the Ethernet IP interface, and I'm going to connect it to the switch 1, which was previously in that project. The next thing I'm going to do is put a GuardLink relay. So I open up safety relays, and you can see the entire GSR family of relays is here. Here's the GuardLink relay, and I click, drag it up, and then drop it into this location. So now at this point, we're going to add our GuardLink network. So right mouse on this module, and then it says attach to GuardLink circuit, attach to a new GuardLink circuit, and by default, it comes up to GuardLink 1, and you can name that anything you'd like. They say OK. All right, so here's a view of what we have going on so far. I'm going to zoom in there a little bit, and you can see, so this is a dual GuardLink module. That's what the D stands for, dual GuardLink. And you have 2 channels. Each channel can monitor and handle up to 32 safety devices. And so you can have 32 safety devices on channel 1, 32 on channel 2. There's a bunch of rules that go along with this. So we'll not talk about that at the moment, but IAB does an excellent job in enforcing those rules. All right, so what we're going to do is we're just going to drop on all those devices that I showed you in the slide, the last slide. All right, so the first device is a cable pool. So I'm in my device list, and here's a Lifeline 5. And it's this device. I click, I drag and drop. So there's the device, and IAB picks the tap, and it puts this terminator on the last tap. All right, so our next device is a light curtain. So it's a 450 LE, and we needed a 30 millimeter resolution light curtain. So I click, drag that, I put it up, and what happens is the product configurator comes up, and it needs more information about that light curtain. So here it is, 30 millimeters, it's hand resolution. Our design specified a 1200 millimeter length and a on-off receiver. So we're going to go ahead and put that in there, and we're going to accept it. All right. The next device is a non-contact SensaGuard switch. And our design specified this S17H. So we're just going to go ahead and drop that in. Two more devices. We have a e-stop. We'll put that in. And finally, a guard locking switch that's TLSZ. And we'll take this first one and we drop it in. So there, there it is. Now, by default, what IAB does up here is a trunk length and drop length. So by default, IAB selects 5-meter cables from tap to tap and 1-meter cables from the device to the tap. Our design was not this. And I'm going to show you just real quickly how to change those runs, those distances. So you come to the device, you right mouse on that, modify connection to GuardLink, and we want to get to this node properties. Here's the current by default items that IAB selected. But if we go up to these tabs at the top, here's the drop cable. So we wanted our drop cable on this first item to be 1 meter, and it is. And we wanted the trunk cable to be 20 meters. So I select the 20 meter, say OK, and you can see it's reflected now back on this graphic. All right, so I'll just go through these quickly. Our next trunk is 30, and then we have a 1 meter and a 2 meter cable specified for this light curtain. So you modify and you get to the node properties. We go to the second drop cable, and we said we wanted 2 meter length, and on the trunk we wanted a 30 meter length. And just like that, these parts are all being updated in a bill of material. So now I'm going to go to the SensaGuard, which is 15 and 0.6. So again, right mouse on the device, get to the nodes. This guy here is 0.6 meters, and the trunk we want it at 15 meters. Okay, two more devices. The e-stop, go to the node properties. For trunk, we want it at 20. And we want this to be 2 meters. And finally, this guard locking switch, we want to be 30 meters. This trunk, 30 meters and 1 meter. So we simply go here, click on the properties, trunk cable, scroll down to 30 meters. Okay, so there's our design. And so at this point, we could go check this out. make sure it's complete. There's a wizard in here, and we'll do that in a minute. And at this point, everything looks good. So I want to show you what happens as you start to extend out the line. And so it becomes a voltage drop issue. So notice up here in this ribbon is a voltage at tap. So this is the voltage drop calculator. And you could see you start at 24 volts at the relay, you go through 20 meters of cable, and it drops it down to 23.37 volts. And then as you continue from left to right, you start to drop your voltage. All right, so what happens if we take and we add another device at the very end? And in this case, I could take a light curtain, for example, scroll down in my device list and drag that up into and put it on the end of this string. Or I can come to this light curtain and duplicate it. It's the same 1200 millimeter, 30 millimeter resolution light curtain. So I'm just going to add that, and you can see it comes to the end of the string. And then notice what happens. We get a couple stop signs, and this errors and warning comes up on our ribbon. So if I click that, it's telling me that the voltage at the taps falls below the 20.4 volt minimum voltage allowed. And the tip is that, increase the power supply voltage. Okay. So we've dropped below the 20.4 volts here. IAB gives us this power introduction tap. So I'm going to pull this device, click, drag, and put it at the end of the line. So notice that, it didn't help these voltages at all. And that makes sense because the power supply is not feeding from the right to the left. It does not backfeed. It only affects the voltage from the left to the right. And so I need to pull this power supply and this tap and drop it in here somewhere to bump up these voltages. And so what I'm going to do is click and drag, and you can see that line coming across. And I'm just going to drop it in here. And so now you see the voltages past this power supply tap have now bumped back up. And so we're in good shape. The stop signs have gone away, and we're ready to go. So at this point, come up to this to the menu action, and we want to do a project completeness wizard. Project checker is green, so that's good. We'll click on that, and if I look at the networks, it says that it's okay. GuardLink network is okay, and all the other hardware is green. So green's good, no errors detected, so we're ready to go. So the here's the real power of IAB, in my opinion. At this point, I can come up and click on, now, I've verified everything. It's looking good. And now I can go to the project bill of material. I click on this button and just wait for a couple seconds here. And we're going to wait just a few seconds more. And a couple seconds more. Okay, so look what IAB has, it gives us this bill of material and all these part numbers associated with that design. And as I scroll down, everything that we included in the project is now in this bill of material, including some auto recommended based software based on the hardware that we selected. So what you can do here, what is generally done, is to save to Excel. You click on that button, you pull all these part numbers into an Excel spreadsheet, and then you can modify it in whatever way you want. And I should note that these are all list price. So if you have a special pricing agreement, these are showing up as list prices, what would be in Proposal Works. Okay, so that brings me to the end of the demo. I'm going to close out. I'm going to go back to the PowerPoint. And we're going to go to the slideshow. All right, so this is the system that we just built. Then we added a light curtain, and that affected our voltage drop. But then we found that we can add a power supply in the in this series of taps, and take care of that power drop, voltage drop issue. So with that, I just want to thank you for joining in today's Lunch and Learn, and don't know if there's any questions, but is there anything going on out there with the with questions?
Hi, Jim. How are you? You did a great job.
Thanks, Leanne.
We're gonna wait a little bit. I don't see any questions yet, but I know that you and I had talked earlier, and you had some frequently asked questions that people have, and so I thought we could just address those and see if we get any questions in the chat. And so the first one is IAB useful if you're creating a standalone GuardLink application?
Yeah, that's a great question. Let me just go back a slide here. So GuardLink can be used in a standalone mode, meaning that in order for it to work, it does not have to be associated with the Ethernet IP module shown here. Now, if you run it in standalone mode, of course, then you don't get all the diagnostics about the devices back to a PLC and then on an HMI. But surely, GuardLink can be used in a standalone mode. And I went in and built a system without this Ethernet IP interface. And that same bill of material that we saw, you can generate that for standalone GuardLink systems as well. So the answer is yes, IAB is useful for standalone GuardLink applications.
Okay, great. Then can guard locking devices be used on a standalone GuardLink application?
That's a great question. So again, referring to this slide, if you put a guard locking, let me go back there. If you put a guard locking switch on GuardLink, the only way to lock and unlock the switch is through the Ethernet IP module. And so you have to do that from your PLC, and then that signal gets transmitted on the one slide where we showed the command lock and unlock signal. That's how that gets to the locking device. So no, you cannot put a guard locking device on a standalone system. It requires the Ethernet IP module.
Okay, well, let's see if we get any follow-up questions to that great information you just provided us. I wanted to reiterate that you can us even after this live stream has ended at McNaughton-McKay@mc-mc.com. We'll make sure that your question is passed along to Jim, who can respond to you directly. Just be sure to let us know the name of this session in your email. Don't think we have any other questions. So Jim and Amy, thank you for your time today. Thank you for all your preparation, Jim, and the presentation. Thank you for being our resource out in the comment section. And I want to thank all of our live viewers for your time today. We hope it was informative and engaging for you. We ask that you remember to subscribe to the McNaughton-McKay YouTube channel for more industry content, and we look forward to seeing you live again soon. Have a great day.